Hello everyone, for this tutorial video I like to discuss concavity, which is used to determine the exact rate of curvature of a function. The general definition of a function being concave is that it is curved inward or caved inward. So it is concave up when it looks like this or this, and it is concave down when it looks like this or this. We see, if we carefully sketch out tangent lines of each graph, that if the derivative of the derivative, or second derivative, is greater than 0, the function is concave up, and if the second derivative is less than 0, the function is concave down. This may naturally lead you to wonder, what would be the point where the derivative of the derivative equals 0? And this actually has a specific name of inflection point, as a reference to the fact the curvature changes, or inflects. However, we notice that the other part of inflection points is that the concavity must be changing, or it must be less than on one side and greater on the other, or vice versa. So, if the second derivative is 0, but the concavity does not change on either end, i.e. it is still 0 on either end, then it would not be an inflection point. The concavity has to change for it to be an inflection. Since we can see that the second derivative describes concavity, it follows that if the concavity is less than 0 at x equals c, then c is a relative maximum, and likewise, if the second derivative is greater than 0, then c is a relative minimum. However, if the second derivative is exactly equal to 0, then we do not have a specific conclusion on whether we have a maximum, minimum, or neither. We can only get guarantees if it is some value besides 0. Now that we have figured out what the second derivative describes in a graph, we can move on to computing the mean value, or average value, of a function using derivatives. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.